All right, section 2.2, histograms. So, no problem. So in the previous section from yesterday, guys, we talked about frequency distribution, frequency tables, and we said this is an efficient tool, a good tool to summarize data, to partition the data into classes with the frequency number of values in each class. So we talked about frequency distribution, and we said that also these tables tell us more about the distribution of the data. If you see that the frequency of the classes is going up and then going down, so that means you have what we call a bell curve or a normal distribution. Now, today we're going to discuss a visual tool, a graphical tool that can be also used to know more about the distribution of our data set. So we're going to talk about histograms and how we can define the histogram, and then show you how we can use our frequency table to convert our table to a graph, a histogram. So definition: a histogram is a graph consisting of bars of equal width drawn adjacent to each other, period. The horizontal scale represents classes and the vertical scale represents frequencies. Period. The height or the heights of the bars correspond to frequency values. So that's the definition, statistical definition of histogram. So let me show you an example here on how to construct a frequency histogram using, or that corresponds or that represents the following frequency table. Okay. Construct a frequency histogram that represents the frequency table shown. Here's the frequency table. Test scores, frequency. Okay. So you are given, you have the frequency table here, and we're gonna convert that table to a histogram. So this is what we're gonna do. We're gonna draw first the horizontal axis, the x-axis. I'm gonna draw a vertical axis. Actually, I'm sorry guys, let me move my graph a little bit down here. So this is what I want you to do. First, you label your horizontal axis with the type of data that you have, test scores. And then the vertical axis, you label it frequency. And then you're gonna go to the table and take the lower class limits, those numbers only. Not the upper class limits, not the upper limits, the lower limits. All right, you're gonna transfer them to into the graph. Okay, so here we have, let's say, start here with, because the lower limit is 40, first one, 50, and make them equally spaced. 70, 80, 90. And after the 90, guys, if I keep this pattern, the next mark on the x-axis should be what after the 90?
100.
The 100. So these are my lower limits. Those numbers will go on the horizontal axis, the x-axis, the test scores. And then I'm going to construct a frequency distribution, a frequency histogram. So I'm going to look at my frequencies here. I have 2, 7, 10, 15, 9, 3. So I'm going to go up by, let's say, 2. $16. And we're gonna now graph the first bar that represents the class from 40 to 49 with a frequency of 2. Okay. That's the first one. Second is 7 from 50 to 59. It's a 7. And see how the bars are connected, attached to each other, no gap between them. And then 60 to 69, 10. Okay, 70 to 79, 15. And then 80 to 89, 9. And the last bar, 3. Frequency is 3. So this is our histogram. All right, so notice how all I have on the x-axis of the lower class limits. Again, I'm just gonna emphasize that. These are the lower class limits. Okay. If you look at the histogram, you can see that the bars start low, with small heights, and the heights start to increase. The frequency is increasing, the height is increasing at the same time, the height of these bars, and then it start to decreasing. So as a general description of this, we can say that this histogram can be represented by a bell curve. I mean, it's not exactly symmetrical, but loosely speaking, you can say still that the distribution of this table is normal. The distribution can be represented by a bell curve. So here I'm going to say the data set has a normal distribution. Again, remember, normal distribution means the data is distributed according to this bell curve, right? The bulk of the data values are in the middle, Notice here how the area is big here in the center. The majority of, or the bulk of the data values are in the center of the curve, center of here. And then as we go to the left, we have less and less data values. Bell curve. Questions, guys, on the histogram? All right. Now, our histogram or our distribution is not always a normal distribution. Sometimes we have what we call skewness. You have a distribution of data could be skewed to the right, could be skewed to the left. If it is not symmetric, if it's not represented by a bell curve, then it has skewness. Like, for example, if I let me show you here this histogram. Like this. You guys can see that the highest graph is not in the center. It is to the left here. So if you look at the curve, distribution curve that represents this histogram, see how the distribution has a long right tail and it's not symmetric, right? You can see that the highest bar is here, not exactly in the center. And then you have many bar graphs on the right, few bar graphs on the left of this bar graph, the highest one. So this histogram is skewed right, or skewed to the right. Histogram. Another possibility is that the histogram is skewed to the left. Meaning we're going to start with very low frequency at the beginning. And the bars slowly get higher and higher. we reach the highest bar, and then after we reach the higher bar, quickly the bars go down to low frequency, very fast drop in the bars. Okay, so now if you draw the if you draw the curve representing this histogram, it's going to look like this. It has a long left tail. We reach the top. And then the right tail is very short, like that. So this is a histogram that is skewed to the left. Question, guys, on this?
Professor, I have a question.
Yes, absolutely.
So would the skewed portion be the long tail and not the height of the curve?
Correct. Yes, your observation is correct. Your the skewness. If the histogram has a long right tail, that means it is skewed to the right. If it has a long left tail, then it is skewed to the left.
Okay, thank you.
It's based on the length of the longer tail.
Okay, thank you.
Mm-hmm. All right, guys. One more thing about this section, and then I'm gonna move on to the next one. Sometimes you might be asked to do a relative frequency histogram instead of frequency histogram. Construct a relative frequency histogram. So we're going to use the same sample data that we used before, but here I'm going to label the vertical line relative frequency, and here test scores. And where did we start? We start with 40. 50, 60, 70, 80, 90, 100. All right. But before we do our histogram, we need to find our relative frequency. So let me go and get this graph. So this is our original graph. I'm going to now add another column. I'm gonna put here relative frequency. And then I'm gonna find the total frequency that I have, which is, let's add these, 19, 19, and 15. 19 and 15 is, and then plus 12, and that gives me 46 total values. So double check again, plus 15, plus 10, plus 9, 46. Okay. So now the first, and I'm gonna put my results here in percent form. So I have 2 over 46. And that is 4.3%. After dividing and rounding to the nearest tenth of a percent. 7 over 46. 15.2%. %21.7%. $32.6. 19.6%. And then the last class, 3 over 46. 6.5%. Let me check total percentage. I should get very close to 100. 4.3 plus 15.2 plus 21.7. 6 plus 19.6. Total is 99.9%, which is acceptable because of the 0.1% is fine because of rounding up. All right, so I got my percentages. I'm gonna go now and label my vertical axis. Put here the percent sign. And then I have, I'm gonna go up by 10%. The first percentage I have is 4.3. 15.2. 21.7. 32.6. 19.6. And 6.5. Questions? So this is what we call a relative frequency histogram. I expect you guys to know how to do both of them. The standard one, the frequency distribution, and the relative frequency distribution, the relative frequency histogram. Now, again, loosely speaking, if you look at the graph, again, you can see there is a little bit of skewness here. It's not symmetrical, completely 100% symmetrical, but you can say relatively, I mean, it is, since the frequency is high and then goes low, then you might say this is also a normally distributed histogram. Okay. Are you guys with me? If you please type yes, everything is fine. Okay, appreciate it. Thank you. All right. I would like to move on to my next section, the last section today, which is 2.3. I want to talk about other statistical graphs. So in the previous section, we focused mainly on one statistical graph, which is the histogram. But that's not the only useful statistical graph we have. We have other types of graphs that also can be used to learn more about our sample, to know more about the distribution of our data values, to give us more insight into the data that we collected. I want to talk about first the frequency polygon, number one. Frequency polygon. A frequency polygon uses line segments connected to points located directly above class midpoints. Or class midpoint values. A frequency polygon is very similar to a histogram, but instead of drawing bars, we're going to use just line segments and connect the midpoints of the classes instead of the bars. So let me explain again. Using the same frequency table that I have. All right, so here's our frequency table. I'm gonna add another column. And I'm gonna calculate my class midpoints. Again, class midpoints, guys, if you remember from yesterday, is the lower limit. Class midpoint is lower plus upper divided by 2. So 40 plus 49 over 2, that's is equal to 44.5. The next one is 54.5, 64.5, 74.5, 84.5, 94.5. These are my class midpoints. I'm going to put them on the horizontal axis. Again, test scores. And then I'm going to label the vertical axis frequency. And we're going to put our class midpoints. We're going to start with first one, 44.5. All right, these are my class midpoints. Now I'm going to ask you a quick question here. If there is another class before our first one, what is the midpoint of this class? Let's assume there is another one before the 44.5. Then it's going to be what, 34.5. And if there is another one after the 94.5, it's going to be 104.5. Okay. Now, our first point is on the horizontal axis. Remember, this is 34.5, does not exist. There is no class with this midpoint. So we're going to put a 0 and then also a 0 here at the end. And then the frequencies. The 44.5 represents this class with a frequency of 2. '54 is 7. 64 is 10. 74, 15, the frequency is 15. 84, the frequency is 9. 94, the frequency is 3, and then the last one is 0. And then I'm going to draw line segments. I'm going to connect these the frequencies of the above the midpoints with straight line segments. And this is called a frequency polygon. Questions? Guys, the next one we have, we're going to discuss a little bit more graphs, but now we're going to discuss graphs that are related to numerical data, set of data, but it's small sets of data. I mean, we do not have we do not have a frequency table. We have just the actual set of sample data, and then we're going to use certain graphs to represent our sample data. So example, or the next thing we're going to discuss is, dot plot. Okay. All right. So consider the following set of sample data. Let's talk about this. Let's see how we're going to graphically represent this sample data. All right, so consider these, that we assume that we collected this sample data. We're gonna graphically represent this sample data with a dot plot. We're gonna draw a horizontal line. And then on the horizontal line, let's see here, we have seven, 10, 5. So we're gonna start, the lowest one is 3. Six. Okay. So above, for each data value we have, we're gonna put a dot. So let's start with the 7. Oops. First dot. 10 right here. 5. Let me fix something here, guys. So we did the 7, we did the 10, 5, 3, 18, 22, 20, 6, 17, 17 again. Now we have noticed we have 217 here. We're gonna put 2 dots above the 17. 19, 22. These 2 dots on top of each other. 25, 28, 30, 30 again, and 31. You can see this is the dot plot here representing this data. I don't see any pattern in the how the points are spread out. There is no concentration in the middle. There is a gap here, so there is no specific pattern or statistical pattern that I can use to describe this distribution. Okay, so this is the dot plot. All right. You can also take this data and represent it by what we call a stem plot. Instead of a dot plot, we have a stem plot. All right, so with the stem plot, you draw a vertical line. And guys, look at the data values that we have, 7, 10, 5, 3. So some of them are single digits. Some of them are in the teens, 18, 17, 17. Some of them are in the 20s, and some of them are in the 30s. So what I'm gonna do, on the left side of this line, I'm gonna put the stem digit 0, 1, 2, 3. All right, so the 7, I will say it is 0, 7. The 10 is 1, 0. The 5 is 0, 5. So I go back to the first row and put 5. The 3, 0, 3. 18, 1, 8. 2, 2. 2, 0. 0, 6. 1, 7. 1, 7. 1, 9. 2, 22, 2, 2, 2, 5. 2, 8. 3, 0, 3, 0, 3, 1. And that's the stem plot for our data set. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. I think we have 17 values, right? 2, 4, 6, 8, 10, 12, 14, 16, 17. Yes. Okay. So we have the stem plot, we have the dot plot, and the next thing we're gonna do is the bar graph and the pie chart and the Pareto chart.
Hey, Professor, I had a question on the stem plot.
Yes, go ahead.
We don't have to put it in numerical order. We just label or list the numbers.
Correct. No need for an order at all. You just need to put the data values with the same, type together, like the single digits, the teens, the 20. It doesn't have to be in order.
Okay, thank you.
Yeah. All right. So, guys, these dot plots and stem plots are useful because they can show you the distribution of your data. They can tell you whether your data is normally distributed or not, whether it's skewed to the right or not, left or not. And also these plots preserve the original values. As you can see here that we can go from the stem plot or the dot plot straight back to the original set because we still have all the data values in these plots. We did not lose any. When you talk about frequency table, when you divide your data set into classes, and you're counting the number of values in each class, you lose the original values. You just know now the class and the frequency. But those dot plots, stem plots are useful because they preserve the original data values. All right. When you have qualitative data or categorical data, then you use these plots. Okay, graphs for qualitative data. We have the bar graph, the Pareto chart, and the pie graph or the pie chart. These three statistical plots are used specifically for qualitative data. Let me explain with this example. Consider the following frequency table. Grade, frequency. Let's say I selected a random sample from the set of grades that I assigned to my students last semester, and I organized them in this table. Let's say A, 5, B, 12, C, 16, D, 4, F, 2. All right, so notice now my data is qualitative, categorical. We're talking about letter grades, not numerical. So And these are the frequencies. Now, a bar graph is very simple. All you need to do is, give me a second, please, guys, 1 second. So the horizontal, I'm sorry, yes, the horizontal axis, I'm gonna put the category, or in this case, the grades. And then the vertical axis, I'm gonna put frequency. And here I'm gonna write down the categories, A, B, C, D, F. And I'm gonna label my vertical axis. Here I'm gonna go up by 2, 2, 4, 6, 8, 10, 12, 14, 16. And then for the first category, A, I have a frequency of 5. So I'm gonna draw a bar with a height of 5 units. And then the B is 12, a bar with a height of 12. And notice how I left a gap between the categories. Category A and category are separate. The bars are not attached, they're separate. There's a gap here. And then C is 16. D is 4. And F is 2. Okay. So this is a statistical graph for qualitative or for categorical data. Again, notice the gap between the bars. Okay. Now, a Pareto chart is very similar to a bar graph, except the bars are ordered from highest to lowest. A Pareto chart is a bar graph. It is used for categorical or for qualitative data, but with the additional requirement is that the bars are arranged in descending order from the highest bar to the lowest bar. So I'm gonna redo this bar graph again. But I'm gonna see which category is the highest, the C. I have C, so I'm gonna put C first. The second highest is B. And then A. And then D. And then F. Grades. And then I'm gonna do the bars again. 16. 12. And then the A is 5. 4, 2. And I'm done. This is the Pareto chart. Okay. Same as the bar graph, except that the bars are arranged in descending order. Questions? And then the last one is the pie chart. I'm sure you have seen a pie chart before. So again, I'm gonna go back to my original frequency table. Sorry about this, guys. I'm gonna add another column, and I'm gonna put here another column for degrees. So what I'm gonna do, first I'm gonna find the total frequency that I have. Let's see, I have here 17 plus 16 plus 6. That's 39. I'm just checking, guys. 6 plus 16 plus 17, 39. So what I'm gonna do, I'm gonna take each frequency divided by 39 and then times it by 360 degrees. Where did this 360 degree come from? Where does it come from? Actually, because we're gonna draw a circle and the circle contains 360 degrees. So 5 over 39 times 360 times 360. That will give me approximately, I'm gonna round to the nearest degree, 46 degrees for the first category. 12 over 39 times 360. Hundred and 11 degrees. I'm rounding to the nearest whole degree. And then 16 over 39 times 360. 148 degrees. 4 over 39 times 360. 37 degrees. And then 2 over 39 times 360. 18 degrees. Total. Again, the total should be very close to 360. Let me check it. 46 plus 111 plus 148 plus 37 plus 18. I get exactly 360 degrees. Good. So what I'm going to do now, I'm going to draw a circle. And then I'm going to look at the degrees. I have 46 degrees. So this is the center. 46 degrees. This is category A. And then category B is 111. So it looks like this here, 111 degrees. And then I have 148 for C. That's the largest category. And then I have 37 degrees and 18 degrees. All right. All right, guys, so I draw a sector for each category, and I label that sector with the category A, grade A, B, C, D, and F. Also, I need to put the percentages. So I'm gonna go back to 5 divided by 39. I'm gonna use now percentages. So my first category, the A, is 12.8%. 12 over 39. 30.8%. 16 over 39. 41%. And then 4 over 39. 10.3%. And the last one, 2 over 39. 5.1%. And that's the pie chart. I'm gonna check it. I'm gonna add the percentage, make sure that I have 100%. 12.8 plus 30.8 plus 41 plus 10.3 plus 5.1. I have exactly 100%. Questions on the pie chart, Pareto chart, bar graph? These are graphs specifically for qualitative data. You cannot use these graphs, or you can use them only if you have qualitative data, categorical data. Final thing about this section. Sometimes bar graphs are not constructed well or not constructed correctly, either by mistake or on purpose to exaggerate the the difference between categories. The differences between categories can be exaggerated if we do not use correct bar graphs. Let me guys show you what I mean by this. I'm gonna take a picture of the this from the textbook and show you what I mean. Guys, are you with me? If you please type yes. Thank you. So here, guys, this, notice this bar graph is deceiving. The one on the left, look carefully at it. See, look at the vertical axis. See how it starts at 10%. It does not start at 0. So basically, when a bar graph starts at a non-zero value, you're basically looking at the upper part of the graph, not the complete graph. And once this happens, the graph becomes deceiving. Now you think that the bar on the left is much higher than the one on the right, and you can maybe not read the numbers well, and you see, oh wow, there's a big difference between this result and this one here. So this one is a deceiving graph because it starts at a non-zero value. The y-axis or the vertical axis starts at non-zero value. The correct graph is this one here. See how it starts at 0%. And now see how this is now, the left bar is twice as high as the first one. But on the other one, you can see it is much higher than the first one. So we have to be careful, guys. We have to always start our bar graph at a 0 value, not at any other percentage. So that's one thing that you have to be aware of with bar graphs. And then the other one here, also pictographs are deceiving. So we usually do not use pictographs. Let me explain again why with this picture here. Okay. So this pictograph is used to compare the number of adult smokers, US adults, in 1970 and in 2013. Look at the percentages. In 1970, 30% of US adults smoked. In 2013, only 18%. So the compare them, 37 is a little bit more than double the 18%. 37 is 18. But if you compare the pictures, the cigarette here, the size of the cigarette here, is much, much bigger than this one here. The sizes are not proportional to the percentages. Percentages is doubled, but the size is maybe tripled or quadrupled. So usually, in general, pictographs are deceiving. Do not represent actual data because you are using a 3-dimensional picture, a 3-dimensional graph to represent 2-dimensional data. Okay.